Hey David, so I'm going to go through each question in this video. I won't fully solve it because I'm confident once I get you started you're able to solve all of them. So for number 12, the platform on the ends, sorry I didn't plug in my tablet. Alright, so the platforms on the end of the half pipe are at the same height. Okay, so we know, what do we know? We know this. We know that this would be at the same height. And what is that height? That height is going to be 4.2. Okay. How wide is the half pipe? So I want to know what this distance is. So in order to find this distance, well, I know that 0 is going to be one of them. My job is to find out, well, what is this distance? Now, in order to find that, I need to remember that all parabolas are symmetric. So the fact that this is symmetric tells me that I know one of my solutions is at 0. So I need to solve this. My equation was 0.2x squared minus 1.6x plus 42. Okay, so I need to solve when this equation is equal to, well, not 42, sorry, 4.2. Where this is equal to 4.2. Okay, because I know that at this point of the parabola, my height will be 4.2. Because they're symmetric, there's got to be another point over here where my height is also 4.2. So we're solving this quadratic equation for when it equals to 4.2. Now if I just simplify this a little bit, well, the 4.2's will cancel out. If I subtract 4.2 from both sides, then I get 0.2 x squared minus 1.6 x equals to 0. And then I could common factor that. And common factor that looks like I can factor out as 0.2x. And then I'm just left with an x minus. And then if I divide out 1.6 divided by 0.2, that will give me 8x minus 8 equals to 0, which means, what are my two x-intercepts? Well, sorry, not x-intercepts, I lied. What are my two solutions for when this equals to 4.2? Well, x equals to 0 and x equals to 8. So that means at x equals to 0, which we already knew, my height is 4.2. At x equals to 8, so this would be 8 right here, my height is also at 4.2. So how wide is the half pipe? 8, I guess, meters. There's no units given here, so I'm assuming 8 units, let's say. Now, I realize what I just said might have confused you because of this. Because I said, we know what x-intercepts are. Then I corrected myself and said, they're not x-intercepts. Okay, that probably confused you. So let me just explain that a little bit. Where did I get this from? Well, I got this, if I backtrack to the original, I got these x-intercepts, or these, sorry, x values, by solving this equation, okay? Which if I simplify it, becomes this, okay? Now, if I were to graph this equation, would I get this graph? No, I wouldn't, okay? In fact, let me just show you quickly on Desmos. I want to make sure I clarify this. 0.2x squared minus 1.6x. Okay, now, how did I get these two values? Well, I got these two values because I factored this equation. And where did I get this equation? Well, I got this equation by setting the original equation given in the question equal to 4.2, simplified it, and I got that. If I were to graph that, then indeed my x-intercepts would be at 0 and 8. Okay. Now, as you can see, this graph is not the same as this half pipe. Okay. What is the equation of this half pipe? Well, the equation of this half pipe is given to us. It's y equals 0.2 x squared minus 1.6x plus 4.2. Okay. So you can see the difference. This is the equation given in the textbook, and this is the equation we ended up solving because we were setting it equal to 4.2. Okay. Part B. How far would a skater have traveled horizontally after a drop of 2 meters? Round to the nearest hundredth of a meter. So what it's saying is, we know that, let's use green. We know that we start at 4.2, okay, and at some point here, I'm going to drop 2 meters after a drop of 2 meters, okay. So in other words, 4.2 minus 2 is 2.2, okay. So I want to know what is my horizontal distance after I hit a height of 2.2 meters. So I would do the exact same thing, except I'm solving now 0.2x squared minus 1.6x plus 4.2. I want to know when this equals to, not 4.2 now, but rather 2.2. Okay? And once again, when I solve this, I'll get two x values. I'll get this first one, and I'll also get another one over here because it's symmetric. But the only one we're concerned with is the initial one, okay? Because we're starting at 4.2, dropping to 2.2, and we are being asked, how far did we travel horizontally? Okay? Hopefully that helps with question 12. Question 14. A ladder is 6 meters long. Okay, I'm just going to, I haven't read the question yet. I'm just going to get my pencil ready. I'm assuming we'll need to draw a picture. Ladder is 6 meters long. Okay, so 6 meters. If the height of the top of the ladder must be no greater than 10 times the distance from the base of the wall. Okay, so I'm going to stop there, and I know, oops, let's assume that's a straight line. Okay, let's call that the height. Okay, well, if the height of the top of the ladder must be no greater than 10 times the distance from the base to the wall. So what I'm going to do is label this distance from the base of the ladder to the wall as x. And it's saying if the height of the top of the ladder must be no greater than 10 times. So 10 times. If the height of the top of the ladder must be no greater than 10 times the distance from the base, and the distance from the base we're going to label as x, and the height along the wall we're going to label that as 10x. How high will up a wall can the top of the ladder be placed? So what this question is essentially asking is, hey, I have a ladder here, and I know that I could move it closer. So I could, the 6 meter ladder, obviously 6 meters is never going to change. If I move this closer, then I will reach further up the wall, right? And that makes sense. And then at some point, if I have this ladder completely flat up against the wall, then how high up the wall is it? Well, it's going to be 6 meters, the height of the ladder, right? But think about this logically. A completely vertical ladder is useless. The laws of physics will not be working for you. So the certain criteria that we want to follow is that this distance from the wall must be 1/10 of the distance of the height, of the ladder up along the wall. Okay, so that's how we would set up this equation. Now to solve this, I immediately notice it's a right-angled triangle. So when I see a right-angled triangle, I should be thinking Pythagoras. Okay, so then I know I have a squared, or x squared, plus b squared, plus 10x squared is equal to 6 squared, or 36. Okay, so then what do I have here? Well, x squared plus 10x squared is, 10x squared would be 100x squared, right? 100x squared plus 1x squared, I'll get 101x squared equals 36. Okay. Now if you simplify that, and I'm sure you can divide both sides by 101 and then square root the answer, you get an x value of, let's see, 36 divided by 101, and then square root that answer, I'll get an x value of 0.597. Okay, which means the height will be 10 times that, which will be 5.97. So let's see if this makes sense. That means the height along the wall against the wall, the height up the wall will be at 5.97 meters. Now this makes sense to me because it's slightly smaller than the height of the ladder itself at 6 meters. So this ladder is almost completely vertical, but not quite. And this will be 5.97. Okay, and scroll down a little bit, and then this distance is 0.597. And 5.97 is clearly 10 times more than 0.597. And if you want to check, type in your calculator 0.597 squared plus 5.97 squared. That should give you roughly 36. Okay. So what this is saying, it gave you the optimal values. Now you might be wondering, okay, what if I wanted the height along the wall to be at 5.99 meters? So that you're almost utilizing the entire ladder. So it would look something like this. 6 meters, 5.99. Now, that means in order to adhere to the fact that this needs to be 10 times more than this, then this distance down here will be 0.599, right? If that's the case, then type in your calculator 0.599 squared plus 5.99 squared. Will that give you 36? No. It's going to give you a number slightly higher than 36, which means this won't be possible. Okay? Alright. Number 15. Number 15, oh, I never talked about this. Hopefully I didn't assign it. But for number 15, when we talk about initial height and initial vertical velocity, there's a formula for us to follow. Let me just go back to the chapter review. And it's right here. Okay. So gravitational pull causes projectiles, in other words rockets, anything that heads straight up into the sky, to form a quadratic relationship. So rocket up and then straight back down. That is modeled by this equation. Okay. Now, I never talked about this equation because I think it takes away from the idea of a quadratic, in the sense that it feels like it's another formula to memorize. Okay. But what you notice here is this is just your initial height. This is your initial velocity, okay, or how fast you're going initially. And this right here is your gravitational pull of 9.8 meters per second. It's a constant, and it's always given to you. So for 15, it's just a matter of plugging the numbers in. So initial height, 0.61. Initial vertical velocity is 36.85. So 0.61, 36.85, and the g is 9.8. You have yourself a quadratic function. Solve. That's pretty much it for that. Oh, verify the following. So this is just checking that did it stay in the air for 7.54 seconds. To do that, just check the x-intercepts. Maximum height, well, is the vertex indeed that? Okay. And last question, 17. So for question 17, it's very similar to the latter question. It's another right triangle. So length, hypotenuse has 17 centimeters. The sum of the lengths of the legs is 23, so let's call this x, which means this would be whatever 23 minus x is. What are their lengths? So to solve this, all you got to do is, again, Pythagoras, x squared plus 23 minus x squared equals 17 squared. And then expand and solve for x. Okay? Hopefully that answers your questions. If not, let me know, and I'll try to address any concerns or questions you may have. Yeah, take care, David.